Hello everyone, this is the part 2 of the Specimen paper 2022 paper 5. I've already uploaded the first one on my YouTube channel, you can check it out. The link will be down below. Now, when the question 2 starts, they are probably going to give you an equation and then they're going to say, alright, whatever is written here is irrelevant honestly, so you should be first looking at this and later on the question we read it too. So it says you need to make sure that a graph is plotted between 1 upon v on y-axis and 1 upon p on x-axis. This means that you need to make this the subject of the equation. So what I'm going to do is, first of all, I'm going to take reciprocal of this equation. When I take the reciprocal, it will be 1 upon v equals to p over q over p times 1 upon p. So this is how the reciprocal is done. Then what you do is, you already know y is here, you simplify it a bit. So p upon p plus q upon p, and this whole is being multiplied by 1 upon e. So 1 upon v will be 1 plus q upon p, and this will be just like that. Now, because we're more interested in finding, 1 upon e has to be, 1 upon p has to be on the y-axis, so we have to open it up, and when we open it up, it will be 1 upon v equals to 1 upon e plus q over e and p. So we can further write it as 1 upon v equals to q over e times 1 upon p plus 1 upon e. Now we can compare this equation with y equals to mx plus c, and as you can see that this is our x-axis, this is our y-axis, which means the gradient will be given by q over e and the y-intercept is just 1 upon e. So this is how you solve this particular equation. It's not very hard. With practice you can just rearrange things. Make sure you learn to compare this. You've already done in AS, I believe, so it will be easier, not that hard. In the next part, they will ask you to complete a table where they say each value of p has an uncertainty of 10%, and they say complete and record values. I've already recorded some of them. I'll just show you to say one of them to save some time. Now, you see we want to do 1 upon p, 10 raised to minus 3. So if you take out the calculator, it will be 1 divided by 250. So this is exactly 0.004. And you can write it as 4.0 times 10 raised to minus 3. So it's already there, so you just write 4.0 plus minus. Now to find the uncertainty, it says it is 10%. So if the uncertainty is in percentage, then it will be carried forward, which means I got to find the 10% of this. So if I find 10% of 4, then it will be 0.40. So I'm just going to write it as one significant figure right now, but sometimes you can also take it to 2 or 3, doesn't really matter in this table. One thing that you guys need to understand is that you might see that I've written all these values in 2 significant figures. So actually you can either write these values in 2 significant figures or 3 significant figures. Why am I saying this? Because this depends on the values here. So all these values are 2 significant figure, and that's how I got to know that I got to write the minimum significant figure in my data or one more than that. So let me write it. Your answer should be here, minimum significant figure in data or one more than that. So that's how you got to complete it. Now, so when you go to the next part of this question, it says plot a graph and include error bars. So let's see what that means. So I have already plotted some of the points, but I just want to plot one of the points for reference. So the first point we plotted was 4.0 plus minus 0.4. So this is 4.0. We're gonna get to 4.0 and the next value is 1.52. So we are going to go here. This is 1.5. this is 1.52. Now notice that this is the half box. Now when I'm drawing this, make sure that this is the only the amount of thickness you got to use for a dot. Do not make it overly thick, because if you color it like this, it will be wrong. It is considered as a blob, so you have to just mark it slightly and then circle it. Now of course you don't have the zoom option, but even if that's not there, of course you know that if you lightly put the point and then circle it, so that the examiner know that okay, you have a point there, so that's not a big deal. Now the real question is that how do we draw the error bars? Now error bars are basically they represent the uncertainty. The first one is 0.4. Now if I look at my axis where I need to draw, it's in 1 upon p. So you see that from 0.5 to 4, there is a difference of 0.5 and it is being divided by 10. So it means each point is 0.05, which means every 2 dots is 0.1. So I need to draw basically 4, which means that I got to go 0.4 on this side, right? So what will I do? I'll do this is 1, 2, 3 and 4. So this is my error bar, and this is the positive side. I also need to know make the negative one. 1, 2, 3, 4. So this is how the error bar would look. So I got 0.4 on the right side, 0.4 on the left side, because the error bars need to be drawn with respect to 1 upon p. Now the next point is 0.3. So here 1, 2, 3, 1, 2, 3. So notice I predetermined what is the length I need to move, or what each box shows. So you need to be very careful about that. And then the next one is 0.2. So I'm going to draw 1, 2, 1, 2 like that. And the next one is 1. Okay, let me 1, 2, 1, 2 like that. And the last one is about 0.1. That would be 1, 1 like that. Now once you have the error bars, he would ask you to draw a straight line of best fit, and the straight line of best fit and worst fit. So let me tell you what it means. So the best fit line means that it should be a line which should equally divide points above and below it. So I will try to attempt it now. So as I can, I'm trying that it should go like most of the points, come on my line to top. Let's try to make it a bit steeper. Does it serve my purpose? Okay, now if you check this out, basically what I've done is I have basically tried that 2 of my points should be like on the top of the line and 2 of them should be at the bottom of line. So if you notice that this point right here and this point is almost at the bottom of the line, whereas this is very close and that point is above. So basically it's almost a best fit line. So for the best fit, it is not necessary that each point basically goes through, the line goes through each point. The important fact is that it should be such that it should equally divide points on both sides. So because we had like We should have 6 points. For some reason why there are 5. Let me check. I missed 1 point probably. So let's quickly draw that. I think I missed, I drew 4.0, then I drew 3.0, then I drew 2.1, fine, then 1.8. I think I missed 1.8. So 1.8 was 1.5, 1.6, 1.7, 1.8, and it was somewhere, I believe, 0.69, 0. Almost 77. So 0.567. So it should be right here. And the error bar that it has was change the color. It was somewhere of 0.2. So I'm going to draw that. 1, 2, 1, 2. Okay. Now let's fix our line, because I was like confused. How could I fix this? But anyway, now it will be fine. So I'll try to make the best out of it. Okay, now if you notice, 2 points of my line are below, 2 points are above, so now it's a perfect combination. So this would be the best fit line, and then I'm going to mark this as I'm going to write it as my best fit. Then what I'm going to do is I'm going to make worst fit line. So the worst fit line basically is a line that goes through, say, the most extreme error bars like this, and the condition for this is that every error bar must be it should cross every error bar, and it should be the steepest line. So when you draw this, now you see it touches the error bar here, and it goes through all error bars, and it touches the other error bars. So this is the most steepest line I can make, and you are going to then write that it is worst fit. So it is very important to label them, because the examiner should know that you know. Now once you have done it, you will get 4 marks. So you have 6 correctly plotted points. I told you don't need to circle them, make a light dot. Then you got to have error bars correctly plotted, we did it. Best fit line correctly, worst acceptable line correctly, which means it passes through all error bars and should be the steepest one. Okay, so you get the 4 marks for this. So for 2 for this, 2 for this, and then they say determine the line of best fit, include the absolute uncertainty in your answer. Now what you're going to do is you're going to find the gradient of this. Now to find the gradient of this, if I were you, I'd pick the easiest point. So red is my best fit line. First I'm going to solve that. Always make sure that the points select basically are on the line, and you do not take the existing points. It is not nice, and sometimes it may create errors in this. So I have taken this point, and then I'm taking 1 point to be somewhere. I think it should be fine if I take this point. So now I got 2 points. I'm going to write them. So this point, I'm going to little bit circle it so that the examiner know. You can also make more lines connected to the x and y axis, so the examiner knows. Now this point is basically 1.25 and 0.6. So my first point, I'm going to write best fit here, and first point is 1.26 and 0.6, I believe. Let me check. Yep, 1.25, sorry. Okay, then the other point that I want to have is this one. This one is about 4, and this goes till here, which is basically 1.5, 1.45, 46, 47, 48. So this is 4 and 1.48. Okay, so I got 2 points. Now please do remember that here make sure you see the units, everything, because it is 10 raised to power minus 3. So I got to also fix that. Wait a second, please. So this is 10 raised to power minus 3 as well, and now it was 0.6. The other point was 4 into 10 raised to minus 3, and I think that was 1.48. Okay, so these are the 2 points that I'm looking for. Let me just fix it a bit. Then what I'm going to do is I'm going to find the gradient of the worst acceptable line, and I needed to find the uncertainty. I'll tell you how. But before that, let's do that quickly. Okay, I wanted a nice color, so I think I am going to pick orange. Okay, so the green one is the worst acceptable line, so you pick the easiest points you like. One thing that I want to tell you, the points that you pick should be far enough from each other. So this is one point I would like to pick, it's a fixed one, and I'm going to put dotted lines here. And the other point on the green that really interests me is this one, which is quite easy. So I'm going to do this, and then I can pick these points. So the first point is 1.5 times 10 raised to a minus 3 and 0.7. So for the worst fit, I have 1.5 times 10 raised to power minus 3 and 0.7. And the other point I have is 3.5 times 10 raised to minus 3 and about this one. This is 1.2567, 1.27. So 3.5 times 10 raised to minus 3 and 1.27. So I got these points. Now notice that both points that I've taken are at least like 50% away from each other. So do make sure that you follow this rule. It is very important that you do not make a small triangle. Don't take points like this, please. Okay, now first I'm going to find the gradient of best fit line. The formula for gradient is super easy. You write gradient best fit would be y2 minus y1 x2 minus x1. Okay, let's quickly do this. So I'm getting it as 320. Now you also need to check what are the units, because on the y-axis the change in y had a unit of v minus 1, right? And x had a unit of this. So what we've done really is we have divided v minus 1 and ohm minus 1. So basically our units are going to be 320 ohm and per volt. So these are the units, so let's keep it there. Then what you're going to do is you're going to find the gradient of worst. So when you find the gradient of worst, it is going to be 1.27 minus 0.7 divided by 3.5 times 10 raised to minus 3 minus 1.5 times 10 raised to minus 3. Okay, so I'm getting it as 285 now. Ohm V minus 1. Now, remember that the best fit to write the answer, you're going to first find the uncertainty. So, how to find the uncertainty? The uncertainty in the gradient is going to be the gradient of best minus the gradient of worst. So, we had 320 here minus 285. So 320 minus 285, this is 35. Now remember that uncertainty is always written to one significant figure, so I'm going to write it as plus minus 40, and the answer, the best fit is the average value, right? And with the units, of course, ohm V minus 1. So this will give me the 2 marks. Of course, it is overwhelming, but you just need to remember you're going to find gradient of best fit, you're going to find the gradient of worst fit. The best fit is the answer to this question, and to find the uncertainty, you have to subtract the best fit and worst fit and then convert uncertainty to one significant figure, as we have already learned in AS. Alright, now then comes the next part where it says determine the y-intercept of the line of best fit, include absolute uncertainty in your answer. So basically this is the same way you're going to do. First of all, we are going to find the y-intercept of best, and to do that you can use y is equal to mx plus c. The reason behind this is that the graph isn't started from 0, so we can't really directly take it. So we'll have to use this. So we are just going to take one point. You can take any point you want to on the best fit line. So best fit line, I believe, was the red one. So you can take this point. This point is 2.5 and 1. I'm just gonna write 2.5 and 10 raised to power minus 3 and 1 for my reference only. And then I'm going to write 1.0 equals the gradient was 320 and the x was 2.5 times 10 raised to minus 3 plus c. So let's do this. So usually it takes very less time, and try to do it as soon as possible. So let's just solve that first. 320 times 2.5 times 10 raised to power minus 3, 0.8. So 1.0 minus 0.8 equals to c. So 1.0 minus 0.8, this is 0.2. Now I'm going to write 0.2, and I can also work out the unit. It's v minus 1 because y-axis is v minus 1, right? Then what I'm going to do is to find the uncertainty, the same thing. I'm going to find the y-intercept of the worst fit line. So y equals to mx, changing color. So I know that let's take a point on the green line, anywhere that is the easiest. So let me find a good one there. I think I took all easiest points. Okay, let's take, well, okay, so we can take this point. This is 0.6 and this is 1.1 and 1.15. So this is 1.15 times 10 raised to minus 3 and 0.6. So let's do that. So this will be 0.6 equals to, the gradient was 285. How do I know? It's right here, I calculated it. And then this would be, the x is 1.15 times 10 raised to minus 3 plus c. So let's see what you get. 0.6 minus 285 times 1.15 times 10 raised to power minus 3. So this is about 0.27. Okay, now what I'm gonna do is I am gonna just subtract these two. So when you subtract these two, 0.27 minus 0.2, so you get 0.07. So I'm going to write plus minus 0.07 because there are two decimal places. I got to put a 0 here, and then I will write minus 1 here. So remember, you need to learn the rules of uncertainty, and if you do not know them, you can always visit my video on uncertainty on the same channel. So that would be good if you do that. Then it says that using your answer in A, C2 and C4, determine the values of E and Q, include appropriate units. Now we already, in the first part, you're going to go back, we already learned that the gradient is equal to Q upon E. So I'm just going to write it here, that the gradient is Q upon E, and the y-intercept I believe was 1 upon E, but I'm still going to check, forgot about it. Okay, so y-intercept is 1 upon E. Now, they just want us to find the values. You don't need to include the uncertainties right now. The gradient you're going to take is 320. You need to find Q upon E, but unfortunately we don't have E, so we're going to keep it here. This is 0.20, and I can find E from here. So E is going to be somewhat like 1 divided by 0.20, that's 5, and 5, and then I can put it here. So 320 equals to Q over 5, and 320 times 5 would be 1600. So E, basically it is a reciprocal of the intercept, because intercept was V minus 1, which means this is 5 volts, and the gradient was basically equal to, remember, it was ohm, V minus 1, and when you multiply V of 5 there, so it is just going to be ohm, so this means this is ohm. So E will be 5.0 volts, and this will be 1600 ohms. So this will give us 2 marks. Then it says determine the percentage uncertainty in this, so that's pretty easy. To find E, we have to find the intercept, right? So how do we do this? Please understand this. So the percentage uncertainty in C was actually 0.07 divided by 0.20. So I'm going to find the percentage first, multiply by 100%. Sorry, the page is ending. 0.07 divided by 0.20, multiply by 100%. So that's about 35%. So the percentage uncertainty is also carried in E as well, the same one. So this means I'm going to write that the percentage uncertainty in E, because it is dependent on that, so this means that it is the same thing, and percentage uncertainty is the same as the E one, so that's 35%. So I'm going to write 35%, that's super easy. Usually what you do here, everything should be shown, because sometimes you need to, he will check what you've done to find this. Then it says determine the absolute uncertainty in Q. Now, the important thing is that you make an equation, you write the Q is equal to M times E. Now what is the percentage in M? So we're going to find that quickly. So the gradient's percentage basically would be somewhat like, let's find it, gradient was 40, I think, 40 over 320, so let's do that. The percentage uncertainty in gradient would be 40 over 320 times 100, so 40 and 320, let's do it. 40 divided by 320 multiply by 100, so that's about 12.5%. So now we're going to find the absolute uncertainty in Q upon Q, change in uncertainty in M upon M, plus uncertainty in E upon E. So this is how the uncertainty is worked out. We want fractions here, so the fraction for this will be 0.35 and the fraction for this will be 0.125. So the total uncertainty, fractional uncertainty Q upon Q is going to be 0.35 plus 0.125, so that's 0.475, and then basically to find Q you need to multiply the value, which is 1600 multiplied by 0.475, so 1600 times 0.475, so this is 760. So this means the value will be 760 ohms, and that's how we do it. I hope you guys have understood this. If you still have any questions you want me to solve another paper, please do let me know in the comment section, and I will see you. Bye.